Hey guys, this is Geo Notes for section 3-1. We're going to start transformations. It's a new unit. Here's a little puzzle for you. It says, plain geometry is hard enough. What will fancy geometry be like? And it's just a little kid talking. I thought it was a geometry related puzzle. Thought it was pretty cool. Alright, number stumper for you. Here it is. 32 DF is 0 DC. So good luck on that one. And put the answer in the box or in the bucket when you get to school the next day. Alright, let's start with transformations. There's a little video here that I wanted you to see. Let's see if we can get it to work. It's just a little side note, and you'll love the British accent.
Speak maths.
So transformations.
Learn to translate triangles and enlarge your figures.
Alright, let's check it out. Let's just talk about translations, which is one of the transformations.
In the wonderful world of maths, a translation involves moving a figure, let's say a triangle, from one place to another.
Sorry guys, there you go.
We use vectors to describe this movement on the x and y axis. So, if you were asked to translate triangle ABC by the vector 2/1, which means 2 to the right and 1 up, the triangle would move like this. In a similar fashion, a reflection involves reflecting an object in a mirror line, and a rotation involves rotating
That's
an object
all of them we're going to be doing, are
given
those
center.
three to start with.
Sounds easy enough, doesn't it? Now, let's see if you can translate the triangle ABC by the vector -3 over -2.
So we would move it -3 to the left and -2 down.
Well done.
Well done.
You speak maths very
Hey,
well.
thank you very much. Oh, that was just a little side note. I wanted you to see that. Alright, transformations. To change the figure's location, orientation, or size to create a new figure. Now, we're not talking about transformers, which is kind of similar to that, but they're changing their shape and becoming a new figure. A transformation is changing the location, the orientation, or the size to create a new figure that looks the same as the other one. Any of those transformations, the turn, the flip, or the slide, the shape still has the same size, the same area, the same angles, the same side lengths, everything. If we just turn it, if we flip it, or if we slide it, nothing changes about the shape. The shape stays the same. And that's exactly what an isometry is. An isometry is a transformation that is the same size. It preserves distance. Again, if I'm going too fast, you can hit pause anytime you need to. So here are the three transformations. You have a rotation, you have a reflection, and you have a translation. Now the rotation is when you're going to turn something. And you can see the middle point here, and it's turning around that middle point. The original figure becomes the new figure. A reflection is when you flip it. So here was the figure, you flipped it over here, and now it became this side. You flipped it on the y-axis. And then a translation is when you slide something. Take the old figure, you slide it up, and now you got the new figure. Now if you do change the size, it's called resizing, or it's called a dilation, a contraction, a compression, an enlargement, or even an expansion. That's when it becomes smaller or bigger. When you resize it, it was a small one, it became a big one, but if you notice, the angles will all stay the same. It's just the size will change. So that's called resizing. We usually call it a dilation or an enlargement or a reduction when we do it. Congruent or similar. Well, if one shape becomes another, using only turns, flips, and or slides, then the two shapes are congruent. So if you just turn it, if you flip it, or if you slide it, it's going to be a congruent figure. Two shapes are similar if you resize for one shape to become another. You may also turn, flip, and slide it, but if you enlarge it or reduce it, then it's going to be called a similar figure. It's going to have the same angles, it's just going to be a different size. So if one shape becomes another using only rotation, reflection, and translation, then the shapes are congruent. If one shape can become another one using a resize, it's going to be called a similar figure. So if you're using only these, it's called an isometry. Remember congruent? Actually, we could put the word isometry over here. An isometry is when they stay the same size. So congruent would be an isometry. Alright, here we're going to specialize on reflections today. In this section 3.1 notes, we're going to specialize on reflections. You could see the reflection that this mountain makes on the water. Here's your line of reflection right here, is the shoreline. And it reflects perfectly, and here you can see a shape got reflected. This top piece is the farthest north, so this top piece is the farthest south. It's the same thing that's going to match. It's like if you fold it on this line, you fold it, it's going to land right on top. Every point is the same distance from the central line. So this point is this far away from the central line, and then it's also this far away from the central line. This top corner point is this far away, so it's got to be the same distance on the bottom of the line. And the reflection has the same size as the original. Reflections do not change size. The central line, we call it a mirror line, and you can see the mirror is going to keep it the same size. We also call it a line of reflection or a line of symmetry, because if you look at both sides, they're totally symmetrical. This one folded on this line, it's going to land right on top of this one, and you won't even see the bottom one. You'll only see the top one. So it's called a reflection. Now, can a mirror line be vertical? Yes, same thing. You don't have to be horizontal. Could be a vertical line. Here my dog Flame shows a vertical mirror line with a bit of photo magic. Well, I don't have a dog Flame, but they did. In fact, the mirror lines can be any direction. Imagine turning the photo at the top in different directions. The reflected image is always the same size, it just faces the other way. So mirror lines can be vertical, and you would still fold it and land. Mirror lines could be diagonal, and you would still fold it and would still be the same distance away. Mirror lines can be any direction. A reflection is a flip over a line. You flip something over the line, and it's called a mirror line or a reflection. Again, pause if you need to. Okay, now you are going to try a reflection here. I'm actually going to show you what it would happen, but you should go to mathisfun.com and you should play around with the reflection. What you're going to want to do is first click on the red triangle. Click on that, it's going to bring it in this little square right here. Then you're going to click on this word reflect, and it's going to reflect it on this line right here. Click that word reflect, it reflects it on this line, and then you copy onto your paper, onto your notes, what you see on the screen. So let's take a look at it, see if it works. Okay, right here. Click on the red triangle, click on this word reflect, and boom. It shows you the reflection line. It shows you that each one has to be the same distance away from the reflection line, and that's what's going to happen. So you can pause that, or you can look back here, and I'll show you what it looks like too. It should look like that. You draw this line of reflection here, and then you put that in. Now you can pause it if you need to. I'm going to go back to the website for a minute, because you should play around with it a little bit. You should maybe click this figure here, maybe click this line of reflection, and watch how it reflects it on the other side and how it actually looks. Each point is the exact same distance away from the reflection line. You can click on the triangle here and reflect it like on this line right here, and you'll see it's going to like overlap each other. So you can see how the bottom one overlaps with the top one, because they would be the same distance away. So some of them can get a little tricky, so it might be fun to play with it for a little bit so you get used to it. But we got to move on, so we're moving. Okay, here's a couple of sample problems for you. And I want to show you how we can always write a rule for a reflection. So let's reflect this along the x-axis. So what I'm going to do is draw a line on the x-axis. So you can see that's where we're going to reflect it. Now, the first point we're going to reflect is point S, right down here. It's 1, 2, 3, 4, 5, 6 units from the reflection line. So 1, 2, 3, 4, 5, 6 above. So this is going to be point S. Point R was 10 units above. So we're going to use 10 units above, or it's 10 units below. So this is point R. And then T is 6 units below, so it's going to be 6 units above on the y-axis. And then Q is 10 units below, so Q is going to be 10. Now we can't put Q, R, S, and T the way they are. We actually have to put Q prime, R prime, S prime, and T prime, simply because that we've already used Q, R, S, T down here. This is our new figure. So we would connect these. You'd have your new reflected figure right there. And like I said, we can always write a rule for reflection. So if you look at Q prime is the point 0, 10. Q prime is the point 0, 10. So you can see that the x didn't change. So we would leave x here, because that's still going to, if we reflect it on the x-axis, x is not going to change. But y became the opposite. So it's x opposite of y. And you'll see that that would work for every point. If you go over to point S, and you see that S is the point 7, negative 6, and you use your rule, then I bet you that S prime is going to be the same x, 7, and it's going to be the opposite of negative 6, it would be 6. Let's test that and go over 7 and up 6, and boom, there's S prime. So you can write a rule for every reflection. Now let's copy this one on the y-axis. So let's make a line here on the y-axis. And we can, K is 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. That'll be K prime. J is 2 more past that. So it's going to be J prime. And L is 1, 2, 3, 4. So we're going to go 1, 2, 3, 4. And we're going to connect those. That would be your line of reflection there. That would be your reflection. Now, let's see if we can make a rule. Let's see. Now, J was negative 7, 7. So negative 7, 7 from J. The new J became 7, 7. So the new J became 7, 7. So let's see what happens. X changed. So it's opposite of X. And Y did not change. You can see that when you crossed over the x-axis, the x did not change. When you crossed over the y-axis, the y did not change. So just a little side note on our reflection. Okay, looking at a couple other ones. Let's see if we can make some of these rules here. This first one is actually 2 reflections. So we're going to reflect twice. So we're going to reflect it across x equals negative 3 first. So let's go ahead and make a line at x equals negative 3. So it's got to cross the x-axis at negative 3. So if I was to reflect that, let's see, S is 1, 2, 3, 4, 5, 6, 7, 8, 9. So we got to go down 9. 1, 2, 5, 6, 7, 8. Okay, I thought that was going to be big enough. Let's see. A reflection across x equals negative 3, and then a reflection across y equals 2. So let's just do point S, and then we can figure out Q. So S prime is going to be over. Let's see. That would be negative 8, and down. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we got to go down 9, so it's going to be negative 12. So S prime is going to be negative 8, negative 12. And then we want to reflect it across the line y equals 2. So let's draw a line at y equaling 2. So we're going to take this point S and we're going to flip it across this line. So right now, there's 8, 9, 10. We've got to go over 10, which is going to put us at 12. So it's actually going to be the point 12, 12. So let's go down here and put our original S. Original S was the point -8, 6. Our new S, S prime, became 12, 12, or S double prime, sorry, became 12, 12, because here was S prime. S prime flipped down to here, and then S double prime flipped over to here. So let's see what we did. Looks to me like we added 20 and added 6. So we did x plus 20 and y plus 6. Looks like our rule. We added 20 and then we added 6. So if we add 20 here, we would get 30. No, we wouldn't, sorry. We would get 10. My bad. Negative 10. So that would give us, if we added 20, we get a 10. If we added 6, we'd get a 13. So point Q double prime would be the point 10, and then 10, 13. Oh, shoot. I messed up. This is -12 here, guys. You probably already saw it before I did. Okay, so let's go back again. We went 20, positive 20, and we actually went down 18. We got to fix that to y minus 18. Okay, so now we can change our Q. So if we go down 18 from 7, it's going to put us at -11. And that is where our Q double prime would be. We'd be over 10. We'd be down 13. So yeah, that would make our triangle. So this would be Q double prime. And we could find T or R double prime by doing the same thing. We could add 20 and subtract 18. Now here's back to just a reflection, but it's on y equals x. So that would be this line right here, where they're 1 and 1, 1, 2, 2, 3, 3, 4, 4, -1, -1, -2, where y and x are always equal to each other. So that would be the line right here. Okay, we want to reflect it across that line. So we have one diagonal away, so this has to be one diagonal away. That's going to be it. Now we want P. So P is 2 diagonals away. That's right there. R would be 1, 2, 3, 4 diagonals. 1, 2, 3, 4 diagonals. And Q would be 1, 2, 3, 4, 5. 1, 2, 4, 5 diagonals. And that would be the shape that you would get if you reflected it. And see how the shapes are the same. It didn't change. Now let's find out what P prime was. So P prime is this one right here. S prime, R prime, Q prime. So P prime is the point -8, -4. Now look what happened. -4 was now your y. So this is this reflection. Your y is going to be first, and your x is going to be second. So when you reflect something across y equals x, your x and y are going to flip. So this was your x and your y. Now it became your y and your x. So we flipped it around when we reflected it on the y equals x. Okay, last two here. Last two. Right? What are the coordinates of the vertices after reflection across the x-axis? So we need to draw a line on the x-axis. Okay, see that line. There we go. So maybe we'll make it red and make it a little thicker. You can see it. Okay, so there's your reflection line. So let's see what G would be. 1, 2, 3, 4 above, so 1, 2, 3, 4 below. That would be G prime. So G prime is the point 2, -4. G prime is 2, -4. Well, what was original G? G was 2, 4. So what would a rule be here? This was 2, -4. So what would my rule be? Looks like the x stayed the same. And it looks like the y just became the opposite. So x and the opposite of y, and I believe we already reflected one across the x-axis. When we reflected across the x-axis, the rule was x opposite of y. So that's where we're back at, x opposite of y. So D was the point -1 and 4. E was the point -1 and 7. And F was the point 2, 7. So D prime, oh, they already wrote those there, not bad. D prime is going to be -1 and -4, because you're going to keep the x and change the y. Keep the x to -1, change this to -7. Keep this to -2. Nope, sorry, not -2, +2. So +2 and change it to -7. And you could plot those 4 points, and you would have your reflection across that axis. So that would be your reflection. Same thing here. We look for a rule. Let's do point E, and then we could write in the rule and get the other two. So we want it to reflect across the y-axis. So we're going to draw a line on the y-axis right here. And let's just do point E. 1, 2, so we're going to go over 2. That's E prime. E prime is the point 2, 3. Okay, so E was the point -2, 3. Now it's the point 2, 3, so x changed. X changed to the opposite, and y did not change. But it still stayed as a 2. Actually, yeah, no, it came as a -2, and a 3 stayed, so a 3 stayed. So it's going to be 2, 3. This one, the x is going to change to 2, and it's going to stay at 10. This one, the x is going to change to 7, and it's going to stay at 1. So using your formula, you can see the x is going to become opposite, the y is going to stay the same. So 3, 10, and 1 all stay the same. There's your little start of reflection.